Imagine this. In the absolute silence of space, where everything seems to move according to known rules, suddenly an intruder appears. Without warning, without announcement, it is simply there, filling space at a speed we have never seen before. Before we can react, it's already flying away. In a panic, we point all available telescopes at it, start calculations, try to capture even a fragment of an answer. We only have a few weeks. What we saw did not match anything we knew. It accelerated where it should have slowed down. It had no comet tail and did not behave like an asteroid. To some, it seemed like a strange rock, while others whispered that it might be something more. And even today, as it disappears into the darkness of interstellar space, we still ask, what exactly flew past us that day? The discovery came in mid-October 2017 when a telescope in Hawaii captured a bright point moving across the sky. At first, it was nothing special, an asteroid or a comet, as they sometimes happen. But the more astronomers looked, the stranger the image became. Its speed was off the charts. Most objects orbit the sun and move along predictable paths. This one was not orbiting anything, crossing the solar system in one direction, too fast to be caught. The math was clear. It had come from far away, from another star, maybe even another part of our galaxy. It was named Oumuamua, a messenger from afar. The name sounded beautiful, but it was ironic. By the time we named it, it was already gone. We counted the minutes, we counted the days, but we didn't get a repeat performance. In that short time, scientists managed to gather only a few pieces of data, and every centimeter of this mystery proved more incomprehensible than the last. At first glance, it looks like a comet, but it has no coma and does not form a tail. Maybe it was an asteroid that didn't fit in. Its orbit was extremely hyperbolic. It didn't just fly by, it rushed as if it had a destination. Its trajectory was inclined relative to the plane of the planets, as if none of our neighbors had any influence on it. It flew in quickly, past Sochi and flew away even faster. And its shape? We couldn't photograph it directly. It was too small, too far away. But the change in brightness during its rotation revealed something strange. The light pulsed every few hours, a sharp increase, a sharp decrease, then another increase, like a lighthouse passing by. This meant that the object was not spherical. It must have been elongated, perhaps even 10 times as long as it was wide. Imagine a skyscraper rolling in a storm, or a thin disk tumbling uncontrollably. None of the known pieces of matter behave so regularly. It spins chaotically, like a bottle thrown into the air, not like a body rotating around a fixed axis. Its surface was more reflective than ordinary rock or ice. It does not glow in infrared like comets do. The Spitzer telescope did not detect any significant heat signals for several dozen hours. The more we delved into the data, the stranger it all became. But even all these anomalies, the speed, trajectory, shape, reflectivity, chaotic rotation, were not the strangest thing. The strangest thing happened when the object moved away from Soka. Instead of slowing down, it began to accelerate. This should not have happened. According to the laws of motion, after passing near a massive star, the object should lose energy, but instead, a small but measurable additional southward component appeared. Something was pushing it, and these were not inaccurate measurements. Double-checked and taking into account all known factors, nothing explained it. So what pushed Oumuamua? The first suspicion was solar radiation, which pushes objects according to the principle of solar sails. If the object was extremely light and thin like foil, the light could push it. But then it should behave like a thin shell, whereas what was observed here was chaotic friction, irregular reflection, and no thermal signal, which this shape usually gives. Another idea was to explain it by gas exhalation, as in comets. Heating the interior causes gas to be ejected, creating jets that change the trajectory, leading to acceleration. But here we did not see any coma, dust, or dust. Spitzer and other instruments searched for escaping gases and found nothing. Two uncomfortable options remain. Either we were dealing with an unknown natural phenomenon or with something unnatural. The latter idea was taboo, but it began to be whispered more and more, especially by one of the most prominent astrophysicists, Avi Loeb. Loeb is not a rumor monger. He is a Harvard professor and author of numerous scientific papers. He pointed out a simple fact. None of the standard explanations fit. The object is searching, maybe strangely shaped, is accelerating, and at the same time we do not see typical signs of activity. He asks the question that many are ashamed to ask. What if it is not natural? He presents a hypothesis that it may be a fragment of technology such as a solar sail, a thin structure propelled by photon pressure. He calculates that a very small thickness, a fraction of a millimeter, would be enough for the radiation effect to explain the observed acceleration. This would explain the absence of visible gas and the lack of a coma. Reactions in the scientific community were mixed, with some rejecting the idea as too sensational, but the majority preferred to exhaust natural explanations. And so began a race of ideas. From a spinning stone to an ice block from a distant molecular neighbor, every idea was tried to fit the facts. Hypotheses emerged about blocks of frozen hydrogen, thin sheets of nitrogen, and strange crystal formations. Many of these ideas had their flaws. For example, hydrogen ice is extremely volatile and rarely travels through the interstellar environment. There is also the concept of a dark comet, a body made of normal ice, but bombarded by cosmic radiation for millions of years, in which pockets of gas trapped under the influence of warming are released secretly without the typical dust cloud. This solution was elegant because it was based on known processes and materials. However, for many it remained incomplete. As scientists argued about Oumuamua, they also began to ask other, deeper questions. If such silent, invisible accelerations occur to objects coming from outside the solar system, why shouldn't we have similar phenomena within our own system? A team of researchers began searching catalogs of nearby asteroids, tons of data, and many years of observations, and found small deviations. Several small bodies close to Earth showed subtle accelerations not caused by gravity. These were not comets in the classical sense. They did not eject dust or form comas. Among them was a tiny fragment named 1998 KY26, rotating very quickly, planned as a target for an extended mission of the Hayabusa 2 probe. Suddenly, a simple research mission took on a new dimension. Instead of just observing, we could gather evidence at the source to see if there are objects with a hidden breath in our neighborhood. This is important. If dark comets are real, Oumuamua may not be a one-off event. We may have a population of objects that are hidden from our telescopes, yet moving in a significant way. Then came August 2019 and another surprise. Gennady Borisov discovered another visitor from outside the solar system. This one has all the characteristics of a classic comet, a bright coma, a long tail, and spectacular gas release. Compared to Oumuamua, it was almost a familiar alien, but predictable. The differences between these two visits show one thing. Space can send us both objects whose nature we can fit into familiar frameworks and those that challenge our paradigms. And this is important not politically, but epistemologically. What we see teaches us how to look further. What next? Should we chase the only specimen that managed to escape us? The Lyra project and other concepts consider pursuit missions, using gravitational assists and maneuvers near the sun to achieve speeds of tens of kilometers per second and capture the object. Difficult, expensive, risky. The alternative is to prepare better for the next visitor. Observatories such as Vera Rubin, formerly LSST, will scan the entire sky with unprecedented speed and sensitivity, detecting moving points much earlier than before. Thanks to this, we will have a chance to send probes to meet them rather than chasing them in panic. Commentators and engineers are talking about missions such as Comet Interceptor, which will be on standby, ready to launch towards a new arrival. This changes the game. Instead of one chance in 100 years, we may have dozens of encounters in a decade. But it is important to remember one thing. Oumuamua was not just a technical problem or a challenge to Newton's equations. It was a test of our imagination and humility. It forces us to ask whether science can accept the most uncomfortable hypotheses and treat them seriously, not with sensationalism, but with genuine curiosity. Avi Loeb says, "Science is a dialogue with nature, not a collection of prejudices." Was it a technological failure? Maybe. Was it an unusual comet? Maybe. For many, the answers will remain uncertain. And that's okay. Oumuamua is valuable not only because it provided cool evidence, but because it encourages us to look wider, to prepare better tools, and to ask difficult questions. If we don't light it then, at least it will teach us something fundamental, that we are still at the beginning of the road, that the universe is more active and complex than we imagine. Every mission, every article, every night spent at the telescope is not just an attempt to find answers, but an exercise in readiness, because another messenger may already be on its way. And next time, thanks to better telescopes, ready probes, and a little courage on the part of scientists, we may be ready to welcome it better. So the next time someone says it's just a rock, remember, sometimes a rock is just a rock, and sometimes it's a gateway to questions that change the way we think about the universe and ourselves. We don't have to assume right away that it's alien technology, but we do have to be smart and brave enough to consider the possibility without fear or loathing. Because the greatest discoveries begin with honest questions and instruments ready with answers. And if Oumuamua played any role in this, it was a reminder. Observe carefully, ask boldly, prepare patiently, because the universe never ceases to surprise us.